Oh my God, that's trippy. This Hangout is on air. Awesome. Let's go down here and I'll start this. Okay, so this is really TDD 101 from the ground up for someone that's never ever heard of test-driven development and doesn't really know how to do it. So some people in this room may know more than perhaps I deal with here, but there's still some good stuff at the end. Okay, so same slide for people that don't know me, which is exactly none of you. I write code. I like writing code. I write a lot of code. So test-driven development is a development practice built around quick feedback cycles and patterns and repetition in the way you code. It's very, very simple. You write a test case, you make it pass, and then you refactor your solution. So often this gets called red-green refactor colloquially, but it's really important, and everything that comes out of TDD is based around this very, very core central concept. So TDD was part of extreme programming. I'm going to say created here, but it's more repopularized, rediscovered by Kent Beck in 1999. He originally was hired, I forget the company name, he was hired by a company in 1996 to evaluate their software development process. And what we now know as extreme programming came out of his analysis in the 3 or 4 years following that. So Extreme Programming Explained was the first book. And I believe he worked with Ward Cunningham to popularize a lot of the things that they learned on that project. But it is much older. So the great thing about the internet is you can find brilliant quotes like this. So in Beck's own words, the original description of TDD was in an ancient book about programming. It said you take the input tape, manually type in the output tape you expect, then program until the output tape matches the expected output. After I'd written the first XUnit framework in Smalltalk, I remembered reading this and tried it out. That was the origin of TDD for me. When describing TDD to older programmers, I often hear, of course, how else could you program? Therefore, I refer to my role as rediscovering TDD. So this gives you a little bit of a hint as to literally how old this was, because this predates compilers and tooling, and it's very, very much almost the scientific method applied to software development of applying tests and tests and tests and refining your tests until you get where you need to be. So why do we do it? So it's actually about really good design. It's not much of a secret, but people often still mistake TDD for anything to do with testing. In fact, it's really a terrible name, because what it really does is it drives out componentization in code. It ensures that you only write what you need, and it reduces your feedback cycle when you're developing. Basically, you prove good behavior in your software. What it doesn't do necessarily is test for correctness what the person that asked you to build asked you for. It has no relation to user requirements. It's only very, very loosely related to exceptions test-driven development and other derivatives of that, like specification testing and behavior-driven development. So really, it's a design activity. The verifiability at the end of it is just a really nice side effect. It just so happens that if you got that mental mapping right between what you were asked for and your unit tests, they act as a tool. So really, it's a design exercise, and some people then will call it test-driven design. So it is impossible to ensure bug-free code, but you can prove your code is to spec, and that's really what your tests are. They're a suite of living, verifiable specs. They document what your code can and can't do. They just don't verify that those things that it can and can't do are the right things that it was intended to do. It also doesn't mean no design, which is one of the key criticisms that are thrown at TDD-driven code bases. You know, people say that, oh, test-driven code is all about writing the tests, and it's never really about good software. It's never really about constructing software in the correct ways. But if you actually look at the community, the people that talk about TDD as a really great tool are people like Martin Fowler and Kent Beck and Robert Martin, and they're exactly the kind of people that talk about software design patterns and software craftsmanship and the art of software development. So for someone to say that TDD isn't about design is almost insane, because they're the same people. So very, very simply, how to write a unit test. So you'll need a test framework, a test runner, and an assertion library. And a lot of modern tooling conflate all those things together, but they are very, very distinct things. So test frameworks in .NET, there are a lot more than you actually think. So the big popular boys, NUnit and XUnit, they work, they're good. Galileo and MBUnit were particularly interesting because a lot of the things you see today in NUnit and XUnit actually came from MBUnit in the .NET space. So parallel test running, row tests, data-driven tests, all that stuff in about 2007, 2008 was MBUnit specific stuff. And MBUnit really existed because NUnit and XUnit at the time didn't support those kinds of models. Unfortunately for it today, both those frameworks kind of sucked up and copied those things up. So, in one way, MBUnit succeeded. It made the testing ecosystem in .NET loads and loads better. Unfortunately, it wasn't the person that did it. Fixie is particularly cool. It's a newer, it's probably about 2 years old, not so widely supported and widely seen. But the great thing about Fixie, it's a convention-based test framework. So it removes the concepts of attributes and all the coupling to your test framework. And the cool thing about it is you can customize the way the Fixie runner executes to mimic the behaviors of other test frameworks. So a little bit of an academic fun thing. So MS Test definitely sucks. Definitely exists. Really shouldn't use it. And if you're looking for very specific reasons, a lot of the reasons that MS Test sucks are very explicitly addressed in NUnit. So data-driven tests in NUnit, you get some nice attributes. I believe the last time I checked in MS Test, you make an XML config file that you include in your test project, that it slowly shadow copies to a directory, and oh my God, I just want to stop already. Like, all these sorts of terrible little design decisions make MS Test pretty lame. Don't use it. It's not worth it. There's no noticeable benefit in any scenario from using it, so don't bother. Yeah, generally you'll see NUnit or XUnit in the wild. Test runners. So most of them actually come with their test frameworks. But what you'll find is a lot of people rely on third-party test runners to actually do the grunt work. So ReSharper is probably the most popular one today. Very good, very useful. Test-driven.NET, much reduced in its capacity of late because ReSharper bundled a test runner. But test-driven.NET was the original integrated test runner for Visual Studio. I think the free version became paid, and then people realized that they could just buy ReSharper and get all the other stuff as well. NCrunch is brilliant. I've showed a couple of people it since I've been here. Maybe one of the things we can do in the session later today is install NCrunch, and you can see what kind of benefits that can give you. So NCrunch is a continuous testing tool that originally derived from experiments with a now open source framework called Mighty Moose, which was an exercise in running tests on keystrokes. Assertion libraries. So again, most of the assertion libraries you use, you'll find are just bundled with your framework. NUnit's one is pretty good. It's gone through a couple of syntactical revisions over the years. So they kind of moved from a assert.true, assert is equals model to assert.that something is dot something else, which is a lot more fluent and reads a little bit nicer. I think a lot of that was in reaction to the presence of new assertion libraries like Fluent Assertions and Shouldly that preferred that kind of BDD influence type of language. So the TDD cycle is very small when projected, apparently. So thank you very much, Wikipedia. Basically, you write some production code, make some tests fail, run all the tests. If they're succeeding, clean up the code. Otherwise, go to the start, write a new test, check if it fails, make it pass, run all the tests, and you just keep on doing that and refining it for feature by feature. And that works both for new features and for bug fixing. So if someone reports a bug, the first thing you should do in a test-driven code base is write a test that reproduces the bug and then make it pass, rather than hacking a fix. So the topology of a unit test is very simple. So that's about the biggest example that you should see. This is using NUnit, so you'll notice that we have NUnit test attributes in it. You have some setup and teardown and a test. And inside the test, you'll see the arrange, act, assert pattern. So this is quite important. So tests should never be big, ever. Arrange, act, assert is a pattern for arranging and formatting tests to try and verify and back this up. So you arrange all the preconditions and inputs, you then act on the object or method under test, and then assert that the expected results have occurred. That's it. Nothing more, nothing less. You should use test setup and teardown only when required, and only to minimize the impact of the arrange step in your tests. Assertions have one simple rule. Only write assertions to test a single test scenario in a test. That doesn't necessarily mean one assertion per test. A lot of people say that, but it shouldn't be very many. Always make sure that you're testing one thing in a test. And if you find that that means that you're repeating logic across tests, that's where your test mixture setups and teardowns come in useful. And on top of that, you can break your test down into various contexts. So this will be, I suppose, the more interesting piece for people that have already written a unit test before. So test isolation. Because TDD encourages you to build small classes, you only really want to test the unit of code that you're rewriting. The unit under test or the system under test are two phrases that get bandied around, and some people take it to the extreme and actually use SUT or UUT as the name of the thing that they're testing in their code. Test isolation helps you instrument your code and get further down there. So techniques for test isolation. To isolate your units of code, you can use mocks and test doubles. And there are a handful of different types of these. They help you express concepts outside of the unit of code that you're testing, and they help you take away all the noise from tests that you write. So if I were to say to the room, you know, what is a mock? What would someone say?
It's a means of presenting a.
It's quite hard to define, or it's
avoid using the words like stub and fake.
Yeah, exactly. So, but you're reaching at the right point, because actually test doubles and more colloquially mocks are a collective noun for a category of test isolation classes. They're not all the same thing. And a lot of people write some mocks and mocks and mocks and mocks, right? And what you end up seeing is people use lots and lots of mocks in the code, and maybe they'll use a mocking framework, and you'll end up with these really big, brittle tests built around complex assertions, and they're ugly as hell, and they're the exact opposite of what TDD is trying to drive out, because all people are doing is pushing that complexity out into their tests. But actually, there are ways out of here. So a dummy is a kind of test double. So it's something that implements an interface in your code that you inject in place of a real piece of infrastructure or other class that your code relies on. Importantly, it does nothing. So you use a dummy when you don't expect any behavior at all from the component, when the code you're testing doesn't care what it does. So often they just return null. That's a dummy. Dummies are harmless. You can't really break anything by injecting a dummy, and the behavior of your dummy has no impact. Stubs, different than dummies, because stubs actually have behavior. Stubs do something, but you don't assert against them. So an idea of a stub would be a method that returns true 100% of the time. And if you needed to write another test that returned false, you'd make another stub that returned false. That's all they do. They're a crutch to test something else. They just help you guarantee the code path that you're navigating. Spies, like stubs, have known behavior. The difference between a stub and a spy is that a spy tests the caller. Now, these things can get brittle and complex. So, for example, a spy could be a class that, when called, sets a Boolean flag that says, I was called. This means that in your unit test above, you can inject that spy and then assert on the fact that was called was true. Mocks. So everyone uses mocks for everything today, it seems. But mocks know what they're testing, and mocks are actually dangerous, or they can be. They have canned assertions, which is very, very specific. So a mock, and by extension mocking frameworks, actually assert on the calling behavior specifically. So they will maybe pay attention to the parameters passed in or keep some kind of state. So they are very specifically concerned with the implementation. This means that if you change your implementation, you have to change your mock. So all mocks are spies. And then fakes. Fakes have behavior. Fakes could verify that a parameter called is exactly the same as something it expects, and then behave differently based on that behavior. They're not dumb. They're not just testing the outside. They're propping up a portion of the system. Some fakes can grow so big they need to be tested themselves. So tread lightly, be very, very careful, be wary around these things. So where do mocking frameworks fit into this? So the mocking frameworks are an alternative to hand-rolled mocks. They exhibit the same qualities as a mock. They're concerned with the implementations of functions of calling code. And given that I just said mocks and fakes can be dangerous, that extends quite naturally to mocking frameworks. So what you'll find is if you kind of canvass the opinion of the internet, people fall in love with mocking frameworks and then they fall out of love with mocking frameworks because people that overcommit to them, if I'm going to stretch that analogy of relationships, people that overcommit to their mocking frameworks end up writing tests that are built around mocking, teardown, and setup.
Over mocking.
Right? And it's not very expressive. It doesn't contain much meaning, and it's very, very difficult to debug because even the good mocking frameworks have some fairly hairy syntactical constructs around asserting on behavior, and it's a bit difficult. So you can equally use a mocking framework to produce stubs. So you get around the whole setup and testing of implementation thing, and that's quite a nice compromise. But at the same time, writing stubs is generally so easy that it's almost wasteful to go and grab a mocking framework to do the same job. So as a rule of thumb, always test the outputs of your code rather than the implementations. Testing the implementations and the literal mocking leads to brittle tests that change often. Your tests are going to get messy. They're probably going to get messy because you've got to bear in mind that your tests are production code. They may not ship to a production server, but they are production code. So if you need to refactor your tests, you should do it. They're your guides, they're your specifications. They're the thing that allows you to change your code. So if you let them rot, they're going to be nothing more than a noose around your neck and additional technical debt. The other thing that tests facilitate is continuous integration. So it's very, very simple to think continuous integration stops at some form of nightly build. A build is useless unless it's verified, and the tests provide you the extra certainty around the verification of builds. There are two good books. The first one's better than the second one. The second one's very .NET specific. They're both quite long, amazingly. I mean, the art of unit testing is about 300 pages long. There's some really great advice in both of them. As ever, your mileage may vary with these kinds of, I suppose, pattern-oriented books, especially when it's something as nuanced as testing. So there are some more advanced topics that we can deal with in TDD, like auto setup of fixtures, and maybe we'll do another session that deals with auto generation of test artifacts and things like that, because that's quite interesting and quite useful, but maybe more applicable in real code bases. And that's the end of the presentation segment on 101 TDD. So I'm going to close this down now. Zoom, anyone that's watching outside. We're gonna now move on to a kata. So we've got just enough people, just enough laptops to pair up, which would be quite interesting. So I'm going to continue broadcasting this for anyone watching, and I'm going to type along. So if you hit up GitHub here, so github.com, David Whitney, Code Dojos. And maybe one of the interesting things we can all do if you've not had any exposure to it is go to the NCrunch website and download a copy of NCrunch before we kick off, because it's quite interesting. To anyone watching over the stream, we're going to start talking a lot less now, I expect, but I'll try and keep the narration up. So what this particular dojo is an OCR problem. So the idea is that a bank scanning machine is scanning in a load of account numbers, and they're rendered rather dumbly as what looks like ASCII art in a fixed width file. So what we want to build is we want to build something that parses the ASCII input, taking what we just learned about testing, mocking, and stubbing. So the two stories are, as a user, when I pass a file with a single set of digits, the correct numbers are returned. The second story is, as a developer, when the parser encounters a pattern it doesn't recognize, it throws an exception. So this will be a good way to get us into the practices of test-first development, because I think what we should do is we should just start with a single test case. And we're going to forget about the big list of numbers, and we're going to see how writing tests makes our design emerge from this. So we'll let you all install the tooling now.
NCrunch. Do you apply it?
You can
Or you can just.
download a trial.
One comment?
And I'm going to code it on the screen as we go. So you get to see me fail to finish this kata as well. So some useful information is if you view the raw version of the README here, we can get some fixed width examples. So you might want to copy pasta some of this stuff into your actual code rather than doing it by hand.
Five-star rating. Bought it. Paid for it myself. If the company didn't pay for it, yes. My company. Okay.
So how do you think we'll go about designing this? How do you think we're going to test this? Anyone?
Have an input, have an output. Test it there.
So we need to start outside in, right? So the obvious, what would you write as your first test for this? So the first story, when I pass a file with a single set of digits, the correct numbers are returned. What kind of, as we think about design as part of doing it, what does this design look like?
Surely we should be able to open a file first.
Okay, great. So we've got something that opens files.
Reads it.
Yeah, so
something there.
Right, so what I think we're looking for is some kind of tokenizer. And obviously this is string tokenization on crack because it's actually string tokenization where the string is split over 3 lines. But as the, if I go back here, we see that each entry is 4 lines long. So we've got 4 lines, 27 characters, first 3 lines contain an account number. Okay, so we're only going to deal with a single string. So actually, let's forget about the file. Why do we need to worry about the file? We can do file input. Great. Okay, but what we really have is we have some digits made out of 4 lines of text, and they're 3 wide. So I think the simplest way to start on a test like this is to say, given the first digit, I can pass it. So we've got something that reads a file, something that tokenizes a file into a series of unprocessed chunks, and then something that recognizes the chunks. So knowing that, we can actually test it from 3 different approaches. So what I would probably recommend is start doing the most interesting bit, because we know we can do file access. So we either want to look at tokenization or recognizing a known token. So I think what I'm going to start off doing is I'm going to write a test. And I'm going to write a test that tokenizes a set of strings into some tokens.
I know. Opposite, I think. So we're reading in 4 lines of it, and we're converting that to an actual digit. And we need to replace that as 1, 2, 3, 4, 5, 6.
Right, so what do I want here?
Scans and produces things.
Yeah. And then our system wants to take in this. Yeah. So I think what the bit we're building is taking this as an input, and then we'll produce actual digits.
I thought it was the other one. Cool. Fine.
So shall we concentrate on maybe getting one of these, transforming that one there into a 1.
So one of the things I'd recommend with this is start out by aligning it correctly, because it's all fixed width, so it's going to get very ugly otherwise. So you're probably going to want something like this. And all we'll do is we'll trim the first line, and we'll trim the last line. because it means that our tests can express the exact same business concepts as our code does without any particular ugliness. So let's do that. So the simplest way to use ncrunch is you just turn it on and you get this wonderful wizard. Just tell everything to run alongside, go, bang, and we're done. So now you'll see at the bottom here, ncrunch is initializing and spinning here. So obviously it can't build a single thing at the moment. But now I know where I'm going with this test. Let's give it a meaningful name. So I'm going to use tokenizer, and I always obstinately spell it in English. And what you'll see here is I'm at the red stage of my red-green refactor in that nothing builds. And because I didn't run Visual Studio as an administrator and my disk doesn't have the right permissions, it's going to do that.
Create a test. David, sorry, just regarding your naming convention there.
Yep.
So that's something you'd recommend. I suppose it's unit under test, input, expected output. Is that
So there are about 3 or 4 different ways to do it. It honestly depends on the kind of code base you're in. So I like this for testing single classes. For testing full applications, I like context-driven tests, which have similar naming conventions, but the context or the input might be in your setup, with each test being a series of assertions. So that's an alternate way you can approach it. What I tend to find is for the bigger units, I do that, and for the smaller units, I break down into a test format like this.
Okay.
So I figure there's no point in dogma around only doing it one way when a mix and match of the 2 approaches seems to work better.
I like this approach. Keeps you focused on what you're actually testing.
Yeah. So now I have a method, and some input, and resharper will generate my default not implemented exception, and ncrunch has already decided that test fails. So it's literally that quick at churning it through. So the cool thing about ncrunch is it does it on key press. You don't even have to save the file. So what I'm looking for here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 characters here, and I need to return something. So say I want to return a list of tokens, token. So now I've got a failing test. I can type as much as I like. So my test here, I want to assert that tokens count is equal to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, not 8. Must be able to count. So if I remove this line here, this is now not returning anything. If I return a new list, You notice the test will now fail on the assertion, and it's that quick. I didn't even save it. I didn't save anything. File is still edited. So the other useful thing you can do with TDD is really only write the amount of code that you need to make the test pass. So what I can do right now is I can cheat. I can cheat very, very hard, and I should. So make a new list of token, and I'm just going to fill it up randomly. Tokens, add range, mobile, repeat, new token, 9. There we go, so my test has passed. So I know when given 9 things, I get 9 objects out. Obviously not true at all. Completely synthetic, I completely lied. So the easiest way to now break this is write another failing test. And much like regular code, you'll go through a refactoring pattern. So tokenize, given 1 known character, returns 1 token. Makes sense. So then I'm going to do this, bring it all the way down to 1, and I'm going to expect 1, and that highlights how my test is a poor test. And my implementation is a poor implementation, even not my test. So that test passes, that test fails, I didn't change any code. So now I actually have to do some real work. So what do we actually have here? Well, first, let's change the test. So whilst it's a little bit funkier to read, we don't have to trim characters everywhere. I suppose what we want to do is we want to loop through the input, and we want to chunk in 3s.
Yeah, we will. Sorry, taking point.
So how would we do this? We're going through each line. See, I last did this cat for about 18 months ago, so I don't remember how to do this. It's fine, we'll work through it. So we can either, it must be divisible by 3.
Yeah, can you say this? Well, 3
So let's go through the red green refactor and do it the simplest possible way. So bizarre counter equals 0. Counter equals 3.
Yeah.
Well, counter equals 2.
That's it. So it should be, that's that.
Take 1, 2. And we'll do something here. Else counter plus plus. So that's going to loop through in 3s. And we're going to do it across lines. So, and the great thing about TDD is it encourages you to just hack away until you get an answer, and then you can make it nice. So lines equals input split new line. Because the API for split is rubbish, you have to do this. I'm going to go through each
Now
line.
we've got each line.
Well, dissatisfied.
can we do it an easier way? Can we say
Only one of them.
right? So 3 equally long lines. We can probably chunk from the start of each line. So let's try this.
Okay.
Equals it 0 I plus plot
Is it, and is that relevant? What's the degree?
times
Why? Did I say that correctly?
I plus plus.
No, it's supposed to be. That's pressing down.
I must have figured it out right. It's supposed to run automatically.
Come on.
So now we'll do it all in one.
So what are these? Are these failing or are these no tests?
Well, bad tests. Even the bad test joke is constantly improved.
God, so we need to build them?
Yeah, you've got 2 tests. Those to be next to something else. So that should something like give them.
Is there a secret?
Yeah, that's all.
I just think can give them 9.
Return all tests.
Yeah, one here.
Token.
Yeah.
Returns 9 token.
Current token equals new token.
So you've got the right code to. So that's not bad straight away.
Something's keep execution like that.
So no.
And that's
So just to satisfy
character.
those.
Interesting.
Just to satisfy those tests. Just needs to be able to
Okay. And
count the number of characters and say how many.
so we're scanning through
Yeah.
So we've got to make sure.
I really freak out.
2, 3.
So out of 1 time I get
So each character is 3 characters.
Mm-hmm.
Okay, that's interesting. Let's do that.
So you take the length of the string.
And here's a great example of how I've managed to make a test pass that doesn't do the right thing again. So I'm now creating the right number of tokens
Yeah.
in 100% of all scenarios because I've split the lines and I'm scanning across the top line and adding a token every 3 characters.
But that's the first test. Needs to
Great.
run through
Needs
all
to
the
also
tests, isn't it?
Perfect.
check for them to each one.
This test doesn't, what we test is doing is just saying,
It's not the wizard.
if I give it the string, does it count all the term? Does it count all the character? Does it turn off? Yes. That was it. I should have 9, but it turned off, yes.
Right, so
That's what I think is. One time, that's great. Can we borrow you for a sec?
Yeah.
I think I must have selected the wrong one.
And crunch.
You can do, you want to take the input string.
It's enabled.
That's the old wizard. What's Alex?
Sure. Yes.
Yeah,
So,
yes.
you want to have an if,
Impacted.
if length of input, mod 3, 0, so it's definitely 3, enter 3.
Must be. Okay, so
Count the number of That's what we're doing. That's what we're doing.
is it
Done.
annotated?
Should make sure that the number of dividers is only like 3.
But it's even there.
That's the
So
first.
it did run the test. Otherwise, I'm
Public.
So you ask it to leave it.
try that.
Otherwise it's close.
Might be a little-
Hey, yeah, we're cracking.
Okay, so given a known character, gets the right data, so I need my assertion to be different. Tokens.
Great. That's how we do it.
Okay.
And now what we copy that. Takes a bit of getting used to the keyboard.
Yeah, it's DD shift.
Mostly for each member of the
Copy and
tokens.
paste.
Just do tokens.
You can just do
But I feel like the paper.
You can touch screen if you want.
Great, so I've got a fairing test. So what I've done here is I've asserted that I get the right number for one, the right number for many, but I need to check that the data is correctly tokenized. So all I need to do here
Did you just Google that?
Oh, there we go. Just keep so happy right now.
The magic that was passed.
actually want to add the lines, don't we?
Let's see. So
This
split it on
is-
the split it on the lines.
I plus 3. So it'll go from start offset.
Would you? That?
So it'll go 0 plus 3 and 3 plus 3. So yeah, that'll work. So then
Why is it? No, that's fine. Yeah, that's fine. What's that?
third,
Options you can also do more. I was expecting
I've managed to break this.
So now, let's see, we have cool each line,
Okay.
literally each line, and then break this into chunks of 3. That's good, Jim.
That's mine.
So we'll go through the first line and so for our two-digit line, we'll have 2 chunks of 3.
What's your tokenized supposed to do? Is it,
So
does it
Yeah.
return each character as a token? Or is it?
This.
Yeah.
So this is grabbing each line. So it's going around chunking 3 by 3, and it's going to grab. Sorry, this is wrong here. So it's going to grab from line 0,
yeah,
line
so
1, and line
so
2
one that go
here,
so
and then I'm going to
one
say
go through each
token
line,
dot
and then
raw
remember that these 3 are for the
add
first line,
first,
and then we'll need to remember that
second,
these
third.
3 are for the next one.
But
and
not
then
all
when we go to
characters
the
are
next
3 by
line,
3,
we
are they?
need to.
They're all
That's
3 by.
This
Is it 4
one,
lines actually?
Don't
1,
we want to
2,
do this whole
3.
digit first?
It's 3.
Yeah.
Everything is 3 by 3. So there's white
So I
space
was
there.
thinking if we go through line by line.
1, 2, 3, 1, 2, 3, 1, 2, 3,
take the
1, 2,
first
3.
Oh, okay, so
1, 2,
the,
3.
so
The first
one,
bit we know is for the first
oh,
character.
okay, right, so the digit 1 has sort
When
of
we get
three
to the
spaces,
Exactly.
okay.
I got the whole lot easier.
I is less than.
So what do I have that's wrong? That's right. I've got the parsing correct.
It won't execute. It won't execute.
It's just this that's wrong here because I'm guessing my loop is outbound.
I don't think that's going to execute.
Indexing length must refer to a location in the
It's
string.
C# 4 executes the completion test before and after. Yeah, that's the beginning of the loop.
That's blowing up here.
This isn't working.
No,
No, you're right. Sorry.
indexing length must refer. So a cool end crunch tip is you can break into the first failing test, right at that line, bang. So this is my failing test at that line, but it's not on this iteration of the loop. It'll actually be the last iteration of the loop.
What's input? Okay. What's input dot?
How do you actually convert these tokens to a digital?
Sorry?
How are we actually going to go about converting the tokens to a digital? And then we're going to have
Think about the simplest possible implementation.
Oh, I know.
It's all the.
I said you
carry.
You store the patterns.
Yeah.
Well, there's new lines
That
at the beginning.
literally compare.
Yep. And you can even flatten it all out. So the pattern for a 1 is a flat string with some carriage returns. So if you smush them to a single string, you can perform comparison.
Split it by new line. These going to
So start index 24.
It's in the array.
My length is
that
26.
have characters.
Our start
So
index
split it by new line.
is less than.
If you've got 3 lines that
Oh,
have,
interesting.
you know.
One of my lines here is not the right length.
You have minus. That's it.
And that's why there's a missing space in my source there. And there we go. Works. Okay, so what had happened then is when I new lined it, had trimmed the space there. Bang, green. So I have 3 tests that prove to me that I can recognize a 0 here. So I get the right number of tokens, I get the right pattern of raw data, and I get the right count. And all it actually is chunking 3 by 3. So now we refactor. Let's try something like this. A very, very nice tight loop.
At the moment, this is only going across one line of data, right?
Nope, it's going across all 3. So what it's doing is it's a for loop that's skipping 3 by 3. So I'm grabbing.
Oh, no, I mean, like, if you had this 0 pattern underneath again.
Correct. This is a single line.
Yeah.
And that's a good observation. So what I'll do here is I'll rename this method to tokenize line. And then we do a similar thing for a whole file, where we take a file and we chunk it 3 by 3 into blocks.
Yeah.
And those blocks are then decomposed into tokens. Because one of the things about the original problem was that it said that there would only be around 500 lines each, which we can hold in memory quite trivially. So there is a pure TDD tokenizer. And actually the solution is quite simple, even though at first when we looked at this, we thought, oh God, how are we going to do this? It's actually not that hard. And that's what growing the code through tests gives you. So now, given a tokenizer, we want a bank OCR tests recognises. Nothing more than that. So OCR equals new OCR. Method, and we'll return an int array for argument's sake by enumerable token. That's let's do that. Let's put a token in. And that should go red. Bang, because we've not implemented exception. But now we've clawed apart the two separate halves of this implementation. So this is what I was talking about earlier when I say that the test driving code leads to componentization directly. So now what we can actually do is we can say this new token raw equals new list of string. This is going to be a bit ugly, but we'll go with it. In fact, what we'll do is we'll take that. And then we'll do this. Great, so we've got a known token. And it still doesn't recognize. Great, so now we can implement. And that'll pass because I cheated it again and fudged it. So what I can do here is there's a 0. Great. I'll do a new test, and after a little while I'm going to start refactoring these. I'm going to jump back to this document down here, grab a 1. Well, I can do it by hand. So a 1 is that.
Oh, that's what the graph isn't it? It's like a slash there.
Oh, that's pretty cool. Yeah, of course.
So now we come back here and we're going to need to do something to test this recognizing thing. So what we don't want is a load of crud in here, really. So potentially we can take some dependencies.
How much is this end crunch?
About 100 and something.
Right.
It's expensive comparatively. It's more expensive than ReSharper, which makes it expensive. but it's the amount of time it saves you is unbelievable. So we're kind of running out of time here, but what I would do here is, given this failing test, this is where design comes in. So I don't want to just paste a bunch of patterns to match in here. So what I'm probably going to do is I'm going to take in an iList of I recognize characters, CHA, characters, components here, and we don't know what this is yet. So this is a little bit of a chain of command. So I've got some components here, and all this is going to do is say bool matches, and it takes in a token, and then in string get value token. Actually, I don't like that API at all.
Good job.
So what I probably want is tuple bool string
Is that cover first?
try match token. And then all this is going to do is implement one of these for different characters. So if I implement this, then hopefully I'll take that from my clipboard.
There's a recommended practice. Do you use tuples a lot?
No,
Use it, I mean,
I don't like them that much, to be honest, but they kind of get the job done from time to time. So
same making a two.
exactly, yeah. I prefer a meaningful name for the kind of the data structure you're bringing back personally, but I'd have a private here, a pattern. And probably the simplest thing to do here is to break this out and write a test around this single recognizing function. So that was where my kind of design brain took over. Okay, so I'll break out of here. I have I've now broken this test, it's failing. So if I just put null in here, this will come back to life and those tests will go red again. Now what I want to do is park this stuff and drop down to a lower level. And I'll call this a zero recognizer. It's called matches. It's called try match. Given zero matches. So the test case is this. Nope, it's that one. That'd have been really annoying. Sure they are. Probably recruiters. And then var zero recognizer ZR try match token. The reason I don't like tuples is item one means nothing. True. So that'll go red. He says, probably doesn't build. Does build, public class, public method, no test case. Seriously. Test. And that now goes red. So we drop into here. And it's probably nothing more than pattern string concat pattern equals string concat token raw, I think is the Boolean. Probably that. Return new tuple matches 0. Bang. So there we go. We've got the recognizers chunking together in here. All we do is for each var C in components. So you iterate through all the matches, so result equals C, try match, token, no, not that word at all. If result, item 1, add result item 2, and actually at this point that's a string, so we're going to cheat for now. In 32 we're going to parse it. So obviously this only works for integers at the moment, otherwise it'll break. I hope. No, something very bad's happened here because we put in null. So we'll just do a recognize as a 0. And actually this is a good point here where I'd stop and realize that these tests and these tests are going to duplicate each other. So what I'd do is I'd scrap these tests and use a stub. So I put in a stub that ensures that the OCR class calls the stub for each token. And that's all I'd ever do for this class at all. And then I delegate the testing of the pattern matching to the tests around these specific recognizer classes. So this would be a good point to kind of stop and refactor after making these tests go green. So I would probably do new array, new 0 recognizer in there. I don't know what it's going to tell me to do there. Don't care about that. So I put that in there. I put that in there, and that'll still fail. So what we really want to do is we want to make everything go green before we do any big refactor. So we've got a 1 here. So actually probably what I do is I delete this test.
Got that now.
So now we've got...
That's our takeaway for today.
No, delete the test. So I will delete the test because it'd be duplication, and then I'd split out and write tests around each of the input recognizers. So that, roughly in half an hour, is how I'd approach the problem from scratch, pure TDD.
Cool.
Does that make sense?
Yeah, it does.
Think I went drastically wrong?
No, this end crunch is pretty cool.
It's a shame no one's ever going to think about lessons.
I've mentioned it.
And it got it on.
And this guy, yeah.
Awesome. So I'm going to stop the streaming now from all my rambling. Thank you anyone that was watching offline. I know it was a bit sporadic in the last half hour, but I hope you got something useful from this.